So what about us? Like you and me specifically, in this class, at Montgomery College, in Germantown, where are we getting our drinking water? So Germantown is fueled by the Potomac River. So to show you this map, Montgomery College is up here, and well, I'm at the Germantown campus, but here we have Rockville. Both of them are supplied by the Potomac River. But it's kind of scary when you think about that, because if you've ever driven next to the Potomac River, maybe you want to swim in it, probably not. I wouldn't recommend it. But thinking like, oh, that's where we're getting our drinking water from, like kind of, this is an example where we're kind of pretty far downstream. The Potomac River starts way upstream. So we're kind of getting all the pollution from all the cities that are above us. So our drinking filtration plant has to be like top notch in order to get all those pollutants out. Our drinking water, as well as our wastewater, is all regulated by the WSSC. You have probably seen this before. If you pay like the water bill, you probably have seen this on your water bill. So the WSSC is the Washington Sanitation and Suburban Commission. They do all things water related. And for us specifically, here in Germantown and Rockville, really in Montgomery County, we get our stuff from the WSSC Potomac Water Filtration Plant. Potomac because we're getting our water from the Potomac River. People who are out in Prince George's County and further east, they're getting their water from the Patuxent River. And we have a Patuxent water filtration plant. But you don't need to worry about that. What you really need to know is that you and I, we're getting our water from the Potomac Water Filtration Plant. Now, at this filtration plant, as I mentioned, we have a lot of pollutants coming in. So we need to make all that stuff go away. We need to have crystal clear water that serves all of Montgomery County, that serves Eastern DC. And so in order to do that, there's actually quite a bit of different steps. Now I'll mention these 5. The first one is coagulation. Then there is flocculation, sedimentation, filtration, and chlorination. You're probably familiar with these last 3 words, and you could probably guess what those different steps are. But before I describe them, what I'd like you to do is pause here and watch this video coming up. This video is from the WSSC, I think it's the Potomac plant. If it's not the Potomac, then it's the Patuxent, but they work the same way. In this video, they're going to talk about all 5 of these steps. So try to take some notes on those steps while they're talking about it. On the next slide, we'll kind of go a little bit more in depth, but it's going to be a lot easier if you watch this video first. So go ahead and pause here, and it should be popping up right up above here. And go ahead and go watch that. Okay, welcome back. So hopefully you've watched that video by now. And they mentioned all 5 of these processes and kind of showed those processes a little bit. Here's a diagram taken from the Potomac Water Filtration Plant. You do not need to know everything on here. I just wanted to show where those 5 different things come in. So here in the bottom left is showing the Potomac River uptake. So this is the river and this is the pipe that's coming in. Now you'll see this black thing. It's essentially a grate, making sure that nothing big comes in, no logs or huge stones. So making sure that we can at least get the big debris out. And it travels and travels and travels, and this is where we add that coagulant. You maybe have heard of this word before. Coagulant means to clot. Usually when people use the word coagulant, they're talking about blood and blood being able to clot. Well, we add a coagulant because, well, we don't want water to clot. We want all the stuff in the water to clot. So coagulating is adding a chemical that makes stuff stick to each other. And so this rapid mix is just essentially mixing all of that together. Like, let's mix this coagulant in, and hopefully it starts attaching this dirt together and this dirt together, and it starts making big clumps. In flocculation, it's essentially slow moving water to allow those clumps to start slowing down and start blending with other clumps. If we're mixing it really, really fast, well, it's just going to keep breaking up. So we slow that water down. And you can see in here, you got these smaller chunks and they're starting to form bigger chunks. Then we have sedimentation, when something sediments down. Essentially all those chunks slow down even more and they start falling to the bottom of this tank. In that video, they were showing that. And you can see this pipe along the top. Well, at the top is going to be the lightest stuff. It's going to be, hopefully, mainly just water. And everything else was way too heavy to be able to go over the top anymore. Then finally, that's going to go through a whole bunch of different filters that get smaller and smaller to get rid of some of the smallest organisms. And then finally, I mean, that water's pretty clean. But there's still even smaller things in there, like microorganisms, like E. coli. So what we do is we add chlorine to it. We'll also add ultraviolet radiation, or UV light, which the video also talked about. And that both of those are meant to kill those microorganisms. We also add fluoride, so for your teeth. And then lime kind of helps with counteracting some things. And then orthophosphate. They mention this in the video. And we'll talk more about orthophosphate when we start talking about water issues. But just know that we will come back to that. Once it's cleaned, it gets pumped out of the drinking water facility and into our elevated water storage tanks. And they get pumped into them. And we store water here because, not because we need somewhere to put the water, which, I mean, is kind of the case, but we actually need to put it literally in a tower or somewhere up high because all of our houses are below it, which means when you turn on the tap, you have all this water pressure pushing down on here, and that's actually what makes it flow into your house. There's not really pumps along the way. There's not water pumping it into your house. This is why, like, you can use, when the power goes out, this is why you can flush your toilet, because it doesn't use electricity. There is no pump. It just is on. Same with all your faucets. Again, when the power goes out, you still have water because there's no pump. There is a pump that pumps the water into the storage tank, but that's it. And that's what's really great about this kind of system and using these elevated tanks, is that when the power goes out, that means no, we can no longer fill the storage tank, but it's a storage tank. It has a whole bunch of water in it. So we're good as long as this doesn't empty while the power is out, which, I mean, this can hold a ton of water, like literally more than a ton of water. So that's why we have those tanks. That's why they're so tall. If you've been at the Germantown campus, you know we have one that's painted like earth, although that one is not elevated. It is somewhat elevated, but it's not on a huge tower like this. But that's why that exists, and that's why you have water when the power goes out. So here in the WSSC zone, so looking at, we are curious about Potomac, but again, here's the Patuxent tap as well. Not only do our drinking water facilities need to make sure that we're addressing all those 90 different pollutants, they also have to report it. It's not just like, oh, we've done it, check. They actually have to record their numbers like every single day. Not only do they record the numbers of the water going out of the facility, but they also look at different taps at different people's homes and look at the pollutants inside their taps. So when it says Patuxent tap and Potomac tap, what this actually is someone's house that I went into. It's like, hey, can we get a water sample? Because the water at the station then has to travel through all these pipes into the storage cylinder, back through some pipes and into the household. So here in WSSC, in the Patuxent River, we don't have any violations. Our water's been great. Here's what we're looking for: different heavy metals. We're looking at different nutrients, looking at a couple of different bacterial species. Look, atrazine. We actually measure for atrazine. Remember, that was the pesticide that was causing those sex changes in frog species. Well, we actually regulate it to make sure it's not too high in our water. Different chemicals that are typically from industrial waste. And if you're interested, you can read why they even get there in the first place. But this is great. We're not in violation. We have met the EPA standards. We've really surpassed for a lot of these. A lot of these say ND. That means no data, meaning it was so low we couldn't even detect it with all of our equipment. So that's really good. And then the things that we could detect are low. So if we look at fluoride, for example, 0.67 was found, and we're allowed to have 4. Okay, so we're like pretty below that level. And you can actually say that with a bunch of these different ones. Here we're at 0.02, and the limit is 2. And that's really awesome because we are honestly, we're in a wealthier nation, a wealthier area of the nation. And so we are meeting and then surpassing the standards that are set for us. If you're more interested in looking through this, there's quite a few tables like this. The link is provided below. So in general, the Environmental Protection Agency is who is monitoring our drinking water, both that we consume and that we shower with. And they're making sure that it's safe enough for us to consume. They're monitoring 90 different chemicals and telling the states and telling these drinking water facilities, hey, you need to make sure you're below this and below this and below this. There's 100 different other chemicals that we have found in our water that we are monitoring, but they're not really regulated yet. There's no standards in place, but we're working on it. Finally, the way that we address the pollution in our safe drinking water is different area to area. Here in the Washington area, because we're downstream of a lot of people, we have a lot of different steps. We add a coagulant to start grouping all of those sediment together. We undergo flocculation basins, essentially slowing down that water to let things clump up more. Then sedimentation, we slow it down even more so that all of that stuff starts sinking to the bottom. That cleaner water comes off the top, goes through a whole bunch of filters in the filtration phase, and then finally it gets chlorinated and a couple other things, but it gets chlorinated in order to kill our microorganisms. So there's a lot that's going on to ensure that you always have drinking water, whether there's no power or whether you're using it for your dishwasher.